All right, welcome to this video on parallel and perpendicular lines. It's part of the final lesson for our first unit of geometry. All right, so let's start out with some basic definitions. An assumption that is not necessary to prove is called a postulate. We will have some postulates in this lesson. And a statement that can be proven based on definitions and previously proven theorems, postulates, all of those things is called a theorem. We will be learning more about proving theorems in our next unit. All right, some types of lines that we focus on in this lesson: parallel and perpendicular. Coplanar lines that do not intersect are called parallel lines. And the symbol for parallel looks like parallel lines. Perpendicular, of course, are lines that intersect at a right angle. And the symbol for perpendicular kind of looks like an upside down capital T. Non-coplanar lines that do not intersect, of course, are skew. No symbol for skew, but if you'll remember, I mentioned that it's really easy to highlight a set of skew lines on a cube. So like, for example, the bottom line on the front and maybe this edge up here, this cube in three-dimensional space, those two lines would never intersect. Okay, so now that we've reviewed our terminology that's in this lesson, a few postulates that we will need to know and be able to answer questions about. The shortest distance from a point to a line. All right, a lot of people will say, oh, you just go straight there. And by straight, what they really mean is that you go in such a way that you make a right angle. Because if you do any other segment, it's going to be longer. Because if you look at any other segment, we create a right triangle in which that segment would be the hypotenuse. So the shortest distance from a point to a line is the perpendicular segment that connects the point to the line. Another postulate that we need to know is that parallel lines are everywhere equidistant. Okay, so this means if you take a segment that's perpendicular to both lines in a set of parallel lines, and you do another segment anywhere else that's perpendicular to both lines, those two segments are going to be congruent. The lines don't get closer together or farther apart anywhere. Given a line and a point not on the line, there exists a unique parallel to the line through that given point. So that means if you have a line somewhere and a point that's not on it, there's only one line you can draw through it that is parallel to the given line. So we're going to draw like a little sample, a little bit above the line. It's kind of hard to get it exactly through the point. There we go. That works. So there's only one line, and then there's our symbols for parallel. Now let's talk about a postulate involving perpendiculars. Given a line and a point on or off the line. So in this one over here, the point is off the line. This one there is on the line. There exists a unique perpendicular to the line through the point, whether it's on or off the line. So I'll put the symbol for perpendicular. And so we'll have one here and one here, and there's only one. So there's our postulates about parallel and perpendicular lines. So the next part of this lesson, we look at specifically angles and how they're associated with parallel lines. We need to learn first the types of angles, and then next we will talk about the specific rules when the lines are parallel. So a line that intersects two or more other lines at two different points in a plane is called a transversal. Very important there. So in this picture, T is the transversal because it crosses over lines M and N. Now, when you have this situation, you get some different kinds of angles. 4 of the angles are interior angles because they are in between the 2 lines that the transversal crosses. So all the region in between those lines is called an interior region. So 3, 4, 5, and 6 would be interior angles. All of the angles that are outside the 2 lines, I'm trying not to mess up my yellow transversal there, are exterior angles. So that's outside the 2 lines. So that would be 1, 2, 7, and 8. Now, the only reason we define interior and exterior angles is that so that you understand the other 4 kinds of angles that you really need to know, because they contain the words interior and exterior in them. These 4 types of angles are the ones that you really need to be able to know and identify. All right, the first one is alternate interior angles. So angle 3 and angle 5, you can see angle 3 here and angle 5 there, are called alternate interior angles because they are interior to the 2 lines, they're green angles, and they are on alternate sides of the transversal. One's on the right, one's on the left. And then 4 and 6 do the same thing. If you were to connect alternate interior angles, they kind of make an X. Yes, 3 and 4 are on alternate sides of the transversal, but we already have a name for them. Those are a linear pair. So we aren't going to name angles that are formed by the intersecting lines because we already had a lesson on angles with intersecting lines, including linear pairs and, of course, your vertical angles. So alternate interior angles, we can abbreviate AI. Okay, the next set of angles is your consecutive interior angles. We also call those same side interior. I like that name better, and I'll tell you why in a few minutes. Okay, so same side interior angles are angles that are interior to the 2 parallel lines and on the same side of the transversal. So like 3 and 6, 4 and 5. Okay, and we're going to abbreviate those SSI for same side interior. All right, so alternate interior, 3 and 5, 4 and 6, same side interior. So that's the interior ones. Next, we have alternate exterior angles. Okay, like alternate interior, 3 and 5, 4 and 6, which you can make an X with them. You can also with alternate exterior angles like 1 and 7, 2 and 8. They are exterior and on alternate sides of the transversal. And then our final type of angles are called corresponding angles, which we will abbreviate with a C. They are angles which are in the same corresponding place. So for example, angle 2 up here is on the top right of its little 4-angle group. Angle 6 is on the top right of its little 4-angle group formed by intersecting lines. So 2 and 6 here would be corresponding. Okay, they're right there. 1 and 5 are both on the top left. 4 and 8, another set of corresponding angles, bottom left. 3 and 7, both on the bottom right. So those are all corresponding angles. And those are the 4 sets of angles that you really need to know and be able to identify because they have properties when the lines like M and N would be parallel. All right, so moving along, let's practice using these new words between each pair of angles, whether they're alternate interior, alternate exterior, corresponding, or same side interior. We're going to use that terminology for consecutive interior, same side. Use the abbreviations. I also want us to identify the transversal. That's important that you can do that. See, these new kinds of angles allow us to move to lines that don't share the same vertex. When we did angles and intersecting lines, like linear pairs, perpendicular pairs, vertical angles, they all shared the same vertex. But now we're going to move to angles that we can jump down by moving along the transversal. All right, so let's first look at angles 10 and 16. You'll notice this picture is a little more complex because it has two sets of lines and two transversals. So what I recommend you do is when you're trying to look at a more complex picture, let's look at the two angles that we're trying to make a conclusion about, and let's look at the transversal that connects them, in this case Q, and block out the line that is in no way involved in creating those angles. And that will allow you to, boil it down to just the more simple picture that we did above up here. So if I look at 10 and 16, I can see they are alternate exterior angles because this is the interior region and they're outside and they're on alternate sides. So they're alternate exterior angles. The transversal is line Q for those. Okay, moving along. The next set of angles, 4 and 12. So here is 4, here is 12. Okay, the transversal that connects them is N in this case. So N and L can be the lines, but they can also be transversals if you're looking at P and Q. So it depends on which one you're looking at. These lines, no way involved in creating them. So I can now see 4 and 12 are both on the bottom left. One is exterior, one is interior. So they are corresponding angles, and the transversal connecting them is line N. You can turn your paper sideways to identify them, to make the two lines go left and right like up here, but I can't do that. All right, angle 12 and angle 13, right here and right here. Our transversal that links them is there, so P is in no way involved in them. I can see they are both on the same side and interior to N and L, so they are same side interior. Our transversal connecting them is Q. And the last set of angles in this picture, we have 3 and 9. So let's see, 3 is here, 9 is here. I can see now L is in no way involved in creating those angles. And N is the transversal going along the lines. 3 and 9 are alternate interior, and the transversal connecting them is N. So there we go. Even though the directions here didn't say to identify the transversal, I know it's on one of your worksheets, so I wanted to practice that. All right, some rules now. Okay, when parallel lines are cut by a transversal, I'll draw a little picture here. Oh, let's undo that one. That's not good enough. There we go. Okay, the following pairs of angles are going to be congruent. So now we have the lines perfectly parallel. Corresponding angles are going to be congruent. This angle and this angle are going to be congruent. Angle 1 is congruent to angle 2 because I have here line A. When two parallel lines, A is parallel to B. Alternate interior angles are going to be congruent. So like angle 2 and angle 3 are going to be congruent. Angle 2 is congruent to angle 3. Alternate exterior angles. Okay, I'll let angle 4 and angle 1 be alternate exterior angles. They are going to be congruent. So that's nice. Corresponding alternate interior, alternate exterior. Those are all the angles that are automatically congruent. Then our next set of angles are supplementary, consecutive interior, and I told you that I like to call those same side interior. And I told you that I would tell you why in a minute, and this is why. One, I think it's more easy for you to understand. They're on the same side and they're interior. So like if I make this angle 5 here and angle 2, I can see angle 5 and angle 2. Look at one of them's obtuse and one of them is acute. Okay, so we can see that it makes more sense that those would be the ones that would add up to 180. Also, same side and supplementary start with S, so they kind of go together. So that's why same side is supplementary, or it'll help you remember that. So we would say that measure angle 5 plus measure angle 2 is equal to 180. And other angles that would equal angle 5, here we got angle 6, I'll make that 7, and I'll make that 8, since there's always 8 angles. So we can see when we have 2 parallel lines and a transversal, we are going to have 2 angle measures. You're going to have one angle measure for 4 angles, and then the other 4 angles are all going to be the supplement of that angle measure. So like, for instance, if I said angle 1 was 60 degrees, then angle 3 and 2 and 4 would all be 60. And then all the other 4 angles in green here would be 120. All right, so let's do some problems that will be similar of what you might have to do when you are doing a quiz or a test or anything like that. So in the figure, the measure of angle 9 is 80 degrees. Okay, great. I am going to let that be my blue angle. Okay, great. And the measure of angle 5 is 68 degrees. Okay, great. So that's 68. I'm going to use color coding because it's going to be hard to write all the angle measures on the picture with all these numbers naming the angles. So if the numbers don't have little degree symbols, they're just naming the angles. So the supplement of 80 would be 100 degrees. So we are going to have some angles in this picture that are going to measure 100 degrees. And the supplement of 68 is 112 degrees. So we are going to have some angles in the picture measuring 112 degrees. Because we can see in this picture, these are our 2 parallel lines, okay? So the other 2 lines are not parallel. So we have our parallel lines, and we are going to have 2 transversals going across them. We first have transversal P, so that will allow us to find these 4 angles. And then we have transversal Q going across the parallel lines, which will allow us to find these 4 angles. So if I block out the bottom one for a minute and just use the top one, I can see with that transversal, angle 9, 11, 1, and 3 are all going to match each other and measure 80. And then the remaining 4 angles will all measure 100. All right, I'm going to get rid of that now. I'm going to block out the top. And I'm going to look at the bottom 4 angles. 8 angles, sorry. 7's vertical to 5. And then 13 corresponds to 5. And 15 corresponds to 7. So all of those will be my 68 degree angles. And then the remaining 4 angles will measure 112. All right, so now we have our picture with all the angles that we know what they are. We can just go answer the question. So angle 12 is green, so it's 100 degrees. Angle 4 is green, so it's 100 degrees. Angle 7 is yellow, 68 degrees. Angle 1 is blue, so it's 80 degrees. Angle 3 is blue, so it is 80 degrees. And angle 16 is pink, so it is 112 degrees. So we have all the angles in that picture. All right, the next kind of problem that uses these concepts, we like to call sometimes a crook problem. Okay, it could also be called a broken transversal problem. You can see as you're looking here, you have a transversal that starts out and then boom, it takes off in a different direction. So what we're going to do is break it into 2 transversals by drawing another parallel line through here, which I could have drawn more nicely. There we go. That looks better. All right, and I'm going to make this line parallel to both of the other lines. We'll actually prove later that if a line is parallel to one of 2 parallel lines, it has to be parallel to the other. But that's in our proof unit. All right, so we're going to find the value of x. The first thing I want you to understand to do when you draw this auxiliary extra parallel line is that it does not necessarily bisect this. We don't know that this angle is going to be equal to this one. Don't make that assumption. It almost never is. But what you do then is you do something similar to the previous problems. We're going to look at one transversal with 2 parallel lines and then a different transversal problem with 2 parallel lines. So I'm going to use the angles, any angles I have at the bottom to work up, any angles I have at the top to work down. So for a minute, I'm going to ignore this part of the problem, and I'm just going to look at the top parallel lines and the transversal that goes between them and use my types of angles. I can see this angle is 140 right here, and this angle is a same side interior angle with it. So they have to be supplementary because same side interior angles are supplementary. So I got the top part of the X angle. Now I'm going to work to get the bottom part of the X angle by ignoring the top part of the picture. So this angle is 47. I could find this angle, but really I'm trying to find X, so I need to find the two angles and add them together. So I am going to say, well, wait a minute, this is an alternate interior angle with that 47. So the top part of that is 47 degrees. So now I can get the value of X by angle addition and adding them together and say that X is 87 degrees. So that's how you do a crook problem. You could have multiple crooks in an angle. I mean, you could make a problem with 4 or 5 crooks. We're not going to do that. That's kind of overkill. But when you have 2 crook angles, then you make 2 auxiliary parallel lines, one through each vertex of each crook angle, which means we have 3 parallel line and transversal problems to look at here. My goal is to get the angle that is labeled X. So I'm going to have to find the top part of the X angle, whatever that is, and the bottom part, and add them together to get the total value of X. So I can start at the bottom and work my way up first, or at the top and work my way down. I'll start at the top. It doesn't really matter, to be honest. And keep in mind, we're trying to make those green lines parallel to the other ones. So if this angle is 50, this angle's got to be 50 because they are alternate interior angles. So that helps a little bit because in order to get the X angle, I need to know what this is. And now that I know that that angle's 50, I know this one's 60 because it says they add up to 110. So that's what I'm going to use there. And then, so if this angle is 60, this angle is 60 because they are alternate interior angles. So I have part of my X angle. Forgot to make these parallel, my picture. All right, so now I'm going to go to the bottom and work my way up. So I'm just going to look now at the bottom parallel lines here and transversal. I see a 140 degree angle. This angle has to supplement it because they are same side interior angles. So now I can get rid of this, and I can say X is the 60 and the 40 together. So it's 100 degrees. Okay, so I'm going to stop the video here, and then I'm going to come back and do the second part because I'm limited on time on what I can do in one video. So let's stop here, and then video 2 will cover the constructions.